Hi everyone, my name is Thomas Kim. Today is January 7th, 2020. In this episode, I will discuss when RAII fails, unique PTR is our savior. Say RAII fails. For your information, RAII stands for Resource Acquisition Is Initialization idiom. If you want to know what is RAII idiom, you can click this link and learn what is RAII idiom. In this episode, I created a SmartHandle that deals with Windows kernel handle object. In this episode, I will demonstrate when RAII fails, we can use unique PTR to prevent resource leak. Start File Explorer. I will create a folder, tutorial, and I will create when RAII fails. I will copy the folder path, copy, start Visual Studio Code. Go to File, open folder, paste the folder path. Also, right-click your command prompt, Property, in Start in field, paste the folder. Click OK. You can also start your command prompt. So we are currently when RAII fails folder. Here, I will create RAII fails.cpp. Hit enter. Ctrl V. I will include IO stream, include memory, include exception, include string. We create a class called Qt object. Private std string m name. Public Qt object constant character pointer name no name m name name std cout constructor for name is called std and there. In some future episode, I will explain why I use std and there. Now destructor Qt object std cout destructor for m name. I say this m name is called std and there. In some future episode, I will explain why I use this syntax. This syntax is not to show off. This syntax prevents a lot of mistakes. Don't comment about my programming style. This is bug. This will be our base class. The base class should have virtual keyword. If you don't want to suffer from resource leak when using dynamic polymorphism, your base class should have at least one virtual member. For more information about slicing problem, please refer to this video. Understanding slicing problem is very important when we use dynamic polymorphism. So I will copy and paste for your reference. Now we defined our Qt object. Now we create Qt widget public Qt object. Private, we use pointer mp_child1 Qt object mp_child2. Public, we create constructor Qt object. This is base class Qt base. Now we initialize mp_child2 mp_child2 new Qt object child2 mp_child1 new Qt object child1. Now std cout, sorry, it should be pointer. Here subclass constructor called std and there. Now destructor Qt widget. In the private section, I will create a function void cleanup. If this mp_child1 delete this mp_child1, this mp_child1 null ptr. If this mp_child2 delete this mp_child2, this mp_child2 null ptr. In fact, we don't need if block. In fact, we don't need if block, but it makes our code a good documentation itself. Now clean up std cout subclass destructor called std ender. Some time ago or a while ago, I had a comment asking why you are using this keyword. This keyword is optional. Why you are constantly using this keyword? If you want to know why this keyword is really important, please watch this video. In this video, bug fix in C++ AMP and curiously recurring template pattern, I fixed a bug in Microsoft C++ AMP header file. They made bug because they haven't used this keyword. If you watch this video, you will understand why this keyword is important. Mr. Koshie left a message. Thomas Kim, also your programming style is terrible. std end line is harmful as well. And he is instructing me, in your example, you should just teach people how to define Win32 event class. Using unique ptr is wrong. In the class defining its constructor, in destructors, you define how to release resource. Close handle. Using exception in constructor, it create event API fails. Deterministic exception in future C++ would make it even better. However, even the current exception is better than yours. However, even the current exception is better than yours. Define move semantic. You can also define copy semantic using duplicate handle, which is not possible by using unique ptr. Refactoring all APIs you are going to use with your Win32 event class. wrapping all error code as C++ exception. Then the code is much shorter and clean. This code is just as bad as C-style code. This is how clean the code could become after dealing with all this stuff. No unique PTR, but the code is much cleaner. He gives instructions about what I film in my videos. And he also gives me links. He is very kind person, so giving me links like this. Mr. Koshi, in a few seconds later, you will witness how much unique PTR is useful. First off, Win32 event is kernel object. Kernel object is not 10 times, over 100 times heavier than pure C++ code. And I already created enough videos about Windows API programming. And I already created SmartHandle you probably like using RAII idiom. Just a few seconds later, you will witness how RAII idiom fails and how unique PTR can be useful. Keep watching. Here, we have to initialize this pointer member like this. Now scroll down, void test RAII fails. int main, we call this function try qt widget. Now in the command prompt, dir will be using clang std C++17 RAII fails.cpp, hit enter. CLS, it works perfectly. Now scroll up. First, constructor for Qt base. This base class, the constructor of this base class is executed in this line. Then, even though we initialize child 2 first, the constructor of child 1 is executed. The constructor of child 1 is executed prior to the constructor of child 2. This is C++ standard specification. In C++ standard, the constructor of base class is executed prior to its member field. So, Qt base is executed first. This is bad practice, but I wanted to demonstrate the execution order. Anyway, child 1 is called, child 2 is called, constructor of subclass. This constructor is called, then subclass destructor is called, this message is called, then child 1, child 2, base destroyed properly. However, the real game starts from here. We are going to use dynamic polymorphism. That's why we put Qt base class pointer. So, in real application, we cannot create such a simple program. I will create another function, template, type name, Qt type. Type name, parameter, types, Qt type. This is pointer, Qt factory. Parameter, types, args, return, new, Qt type, std, forward, parameter, types, args. Up to this point, there is no problem understanding. Now copy this Qt factory. Now copy here Qt object. child 2. Now I initialize the second element declared here using Qt factory. Now let's build once again. Our program works correctly as expected. In some case, memory resource is exhausted, so if dynamic allocation fails, new operator throws fed allocate. Now we build once again CLS voila. So constructor for child 1 is called. So child 1 is constructed successfully and exception is thrown here. So this is what you like RAII idiom. This destructor failed. The destructor of this subclass is not called, and the child 1 successfully dynamically allocated. Destructor of child 1 is not called, and subclass destructor is not called. It means this function is not executed at all. Cleanup is not executed. So the memory for child 1 is leaked. Now I will copy this. I will copy up to this point. Copy, paste. I will change the class name. Paste. Copy, paste, paste. And I will change it to std unique ptr. I modified like this. Okay? And we don't need this at all. We don't need this. We don't need this. Now here, test RAII fails, but still works. Now I copy this function, copy, paste, std, cout, std, and there. Here, we have to use this class. Now we rebuild CLS. In this case, test RAII fails. This object, this is what you call RAII. This RAII paradigm failed. The destructor of child 1 is never called, or subclass destructor never called. In this case, subclass of destructor is still not called because it failed in the constructor here. However, it does not leak any memory. Constructor of child 1 is called. Destructor of child 1 is called because child 1 is successfully constructed. In this case, memory leak occurs. In this case, memory leak does not occur because we use unique PTR. In the first example, RAII fails. In the second example, RAII fails but still works using this simple clean class. This is the power of unique PTR. Mr. Koshi left a message like this. That is exactly why I said unique PTR itself is a problem. It does not promote good programming behavior. It makes the interface worse. It is completely useless compared to custom-written RAII class. Mr. Koshi, I understand you like RAII idiom. As you have just noticed, RAII failed relentlessly. You also said unique PTR itself is a problem. Avoid smart pointers and prefer to define copy control class directly. If I am designing my own class, I can do whatever I like. Unique PTR is the best way to program defensively with C-style programs or third-party tools. You said this is how clean the code would become after dealing with old stuff. No unique PTR, but the code is much cleaner. You are talking about Win32 event class. I think you do not understand the consequence and implication of kernel object. As I said previously, kernel object is over 100 times heavier than pure C++ code. This simple code, clean and neat, solved all the problems you mentioned. Above all, this class based on unique PTR is efficient and light, unlike Win32 event class based on kernel object. In future episode, we will use unique PTR to create our GUI application using Qt Toolkit. Please subscribe to my YouTube channel. Thank you for watching.